Welcome back, everyone, to the last day of our Gencade webinar. We appreciate everybody coming back and hope that this last day is really beneficial for you. Before we get started, I have a couple things I just want to mention. First of all, we did get a lot of questions yesterday about when the videos will be available and where you can get them. They'll be available on the SERP webpage at the same location as all of our supplemental material. I have all of the videos on my laptop now. We haven't uploaded them at this time yet, but we're going to probably do that within the next couple days, at the latest middle of next week. So those will be available to you. And then today, we're going to discuss the last case. This one is the more of a difficult case. We're going to go through everything that you would need to know in Gencade. So this would include, in addition to the things that we covered yesterday, those were bringing in initial shorelines, regional contours, wave gauges, inlets, beach fills, and jetties. We're going to also include seawalls, groins, and things of that nature, as well as bypassing and breakwaters. So this case is all-encompassing of what you would cover in Gencade. So we're going to go ahead and get started. I'm going to bring up my Gencade window in the SMS. And we'll just get started with this Long Island case. Just to remind you again, it's on the SERP webpage here. You can go enter Day 3 material. And this is where you'll get the files. You can either follow along now, or when we get the videos up and running next week, we can do it then. After I go through this example, I'm going to talk about a few of the capabilities that we're working on right now in Gencade that we'll be releasing in version 2. Then we're also going to go ahead and Rusty is going to take over, and he's going to talk about the wave conversion tool after that. I think we'll probably be done a little bit early today, unless we have any questions that you want answered at that time. So we can go ahead and get started with the Long Island case. So this is what it's going to look like when you actually download all of the files. So you'll have the aerials, the initial shoreline, your inputs and outputs, as well as your map file, your regional contour, and your waves. And this first part is going to be a little bit of a review. We're going to still have to start over at the very beginning, and I'm going to start with inlets and beach fills, also to get people that may have to start a little bit later, so if they come in a few minutes, they really won't miss anything brand new. So again, when you start up SMS 11.1, you already have it open. Just as a reminder, the first time you use SMS, you need to go Edit, down to Projections, and then define where the location is of your executable. And you do that by going into File Locations, and then scrolling all the way down to Gencade, and then defining the location of your executable. I'm going to click OK. And now we're just going to start this case from scratch. The first thing that we need to do is define the coverage type. And again, we've already done that before, but we need to go to Default Coverage. We're going to right-click. We're going to go all the way down to Type, go to Models, and go to Gencade. So now we're in that Gencade model coverage. The next thing that we want to do is define the projection. So again, this is going to be very repetitive, but this is just something that you'll do each time you use Gencade. So you'll go Edit to Projection, and we're going to go to the global projection, and we're going to define it as UTM Zone 18. The units are meters, and we'll click OK. And then we're going to keep the vertical projection as meters and click OK again. So now we're in the proper projection. All right, so next what we're going to do is we're going to bring in our initial shoreline and our regional contour. And again, we've already done this, but you need to do this for every case. So we're going to go ahead, and this will be under initial. And just to remind you again, when we open up our coastline file, this is what it's going to look like. And this is a more detailed file compared to the simple example we did yesterday. So again, the format, the first line will say coast. 1 represents the one shoreline. And then there's 776 points in this file, which if you scroll all the way down, you can see all the XY coordinates for each point. And then this means that we just do not close, we keep this open, so we're not closing the shoreline. So I'm going to go ahead and bring this into the SMS just by dragging it in. And again, now we just have a black line. It's very generic. And we have to go into the Select Feature Arc. So we'll click here, and we'll double click on the line, and we'll define it as an initial shoreline. And we'll click OK. So now it's turned green. Remember, next, if we have a regional contour, we have to open up a new coverage. So to do that, we need to go to Map Data. We're going to go to New Coverage. And we're going to scroll all the way down to Gencade, which is here. And we're just going to rename the coverage name. I like to just name it Regional Contour since it's easy to remember what it is. And we'll click OK. And now we have that new coverage created. We're going to go back to all of our files. And Gencade, in this Long Island case, I have the regional contour in this folder. I'm going to open it up and bring it into Gencade. So again, it comes in as a generic arc. We're going to click on Select Feature Arc, and we're going to double click, and then we're going to go to Regional Contour and click OK. Next, if you remember from yesterday, we need to merge these into one coverage. So to do that, we're going to click once on Default Coverage. We're going to hit the Control key, hold it down, and then click on Regional Contour. So now they're both highlighted. We're going to right-click and then go to Merge Coverages. Do you want to delete the coverages used to make the merge coverage? I usually say no. Now we have the merge coverage here, and you can tell if you zoom in that we have both coverages in place. Next, I'm going to bring in the aerial photographs. And for this case, I have several aerial photos. We have some very detailed ones and then some more less detailed but larger aerial photographs. So I'm going to bring all of these in, and this just might take a minute or two. I'm going to get this pop-up about generating image pyramids. I'm just going to say no, and I'm going to bring in all of these JPEGs. All right, so now we're actually only seeing one of the images. This is this image is actually on top of all the other ones. So what you can do if you want to see these other images is you can just click on this image and drag it up. So now you'll see all the other images on top of that other image. I just wanted to show you the separate images now so you can actually see where this is located on Long Island. I'm now going to just uncheck this coverage here, this this image just because it's very large, and what happens is it really slows down when you're looking at different parts of if you go to different images. So I'm just going to remove that for now. So now we have our aerial photographs, we have the initial shoreline, and we have the regional contour. The next thing I'm going to do is just start again with the inlets. I'm not going to go into as much detail as yesterday, but just as a reminder of how you would go ahead and develop your inlets. So the first inlet is located in this area here. So I'm going to zoom in to the inlet, and this is Shinnecock Inlet. So I'm going to go ahead and go to create the feature arc, and I'm just going to draw an inlet here and double click to end my inlet. I'll go to select feature arc and double click. Again, going to my Gencade arc attributes menu. I'm going to click on inlet. I'm going to go to attributes, and now I can define all the information about my inlet. I'm going to call it Shinnecock. I'm going to define my inlet volume. And for this particular inlet, we do have some information, so I will just type this in now. And you can also follow along if you have, if you've printed out the copy of the supplemental information. There is a listing of what steps to follow to develop this example. $2.2 million and 4 million cubic meters. $600,000. So I'm going to go ahead and click OK. I'm going to go to dredging. And then we're just going to repeat what we did yesterday. So we're going to start our beginning date, which is July 1st, 1984. And then August 1st, 1984. We're going to click on the shoal to be mined, and I'm going to click ebb, and then I'm going to enter my volume, 134,562, and we'll click OK, and OK again. There are additional dredging events for this case, but I'm just going to ignore those for now since we've already done dredging since we did that yesterday. And I'll click OK. The next thing we're going to do is develop our left and right jetties. And if you remember from yesterday, if you're sitting in the middle of the inlet, so you're here, and you're looking out towards the water, your left would be to your left. So this jetty here is considered your left inlet, or your left jetty. So I'm going to go ahead and draw that by going to Create Feature Arc, and then just drawing the arc here. I'm going to do the same thing for the right. And then I'm going to go to Select Feature Arc. I'm going to double click. I'm going to name this my left jetty on inlet. Go to my attributes. And then I'm going to define them here. The permeability is 0. It is diffracting. And we're going to say the seaward depth is 3 meters. And then we're going to do the same with the right jetty. Another thing you can do here is, say you've drawn your jetty and it's not in the right location for what you want. You can always move this around in the conceptual model. And how you would do this is by going to the Select Feature point. You would click on this point and you can actually drag it around to the new location. So that's a simple way to make changes to your arcs without having to delete them and then start over. I'm going to continue on to my next inlet. So here we are at the next inlet. And we'll just do the same process. And again, I'm going to go through this fairly quickly. We'll draw my inlet here. And I'm also going to draw my jetties. Then I'll go to Select Feature Arc, and I'm going to define each of these now. So this arc is my left jetty on the inlet. I'll go to Attributes. I'm going to define this as diffracting with a seaward depth of 5, and I'll click OK. I'll do the same for my right jetty on the inlet and click OK. And then I'm going to do the same thing for the inlet. I'm going to go to Attributes. I'll name my inlet. And now I'm going to enter in all of my information for the inlet. We'll click OK. Then we'll go to dredging events. And again, I'm just going to add one dredging event just to remind you of this. This begins on July 1st, 1985, and it ends on August 1st, 1985. We're going to shoal. The shoal to be mined is the ebb shoal, and the volume is 271,417. We'll click OK, OK again, and OK again. And then there is another inlet here. I'm just going to ignore that for now, and I'm going to go to this last inlet here, which is Jones Inlet. And I'm going to do the same thing here, and then we'll move on. So I'm going to draw my inlet. I'm going to draw my jetties. And then I'm going to enter in all of my extra information here. So I'll define this as an inlet. I'm going to go to Attributes. I'll name my inlet. And I'll enter in all my information here. One nice thing you can do here is if you have multiple shoals that have the same volume, you can just click on this little white square here. If we double click, it will extend it until the end of your shoal volumes. So that's another nice little time saver. And we'll click OK. And then again, we would have dredging events, but just to save some time, I'm just going to ignore that for now. And I'm going to go ahead and save this. And I'll just name it as my Long Island demo. And click Save. And remember, we're in the conceptual coverage now, so we're only going to have files for the SMS, the project file, as well as the map file created right now. I also need to define each of these jetties, so I can do that quickly. This is the right jetty on the inlet. We'll go to Attributes. We're going to say the permeability is 0.2, diffracting, and seaward depth of 7. Click OK. And then we'll do the same thing with the left inlet on the jetty. Left jetty on the inlet. And a depth of 7. We'll click OK. So now we've done everything with our inlets and our jetties. I'm going to quickly go through a couple of the beach fills just so you can remember how to do this. We have a couple of beach fills here, and I'm just going to go to this frame, and then this will scroll me all the way out. I'm going to go back near Shinnecock Inlet because we have a beach fill in this location. And remember, I can draw this shoreward or landward. It really doesn't matter the location as long as we get the right area so that we have it referenced to the proper cell numbers. So I'm just going to draw this from near the jetty to this point here. Then I'm going to go to Select Feature Arc, double click, and I'm going to open my arc attributes and call this a beach fill event. I'll go to Attributes, and one nice thing that you can do is, for an example where you have the same beach fill but it's renourished, we can actually enter multiple beach fills for one arc. So for this case, what I'm going to do is the first beach fill starts on April 1st, 1984, and it extends till May 31st, 1984. So I'll enter that information. And then we'll have our added berm width. And then if I click here, we can enter a second beach fill event at the same location. So here, I'm going to enter April 1st, 1990. And then May 31st, 1990. And then it would be the same added berm width, although you can enter different berm widths regardless, even in the same beach fill event. I'll click OK, and OK again. And now it's going to turn green. So that's as far as we got yesterday. So now the next thing we're going to do is develop a seawall. We have one seawall in this particular case. We're going to scroll here near the last inlet. And we actually know there's a seawall protecting this building here. So I'm going to scroll in a little bit more. And I'm going to do the same thing as I have done for the previous arcs. So I'm going to go to Create Feature Arc, and I'm just going to draw the seawall. So I can start here. If I click once, that will end and we'll have a vertex, and we'll just continue making the seawall. And then double click to end it. To name this a seawall, we'll go to Select Feature Arc. We're going to double click on it, and we're going to name it Seawall. And click OK. And now the seawall is going to turn dark blue. So seawalls are very easy to create. We don't have any additional attributes there. So now that I have my seawall, I also want to add some groins. And we have a groin field. I'm not going to make every groin in this case, but I'll show you a few of them and I'll show you how to do this. So we're going to scroll back out, and these groins are located in this section here. So I'm going to scroll in, and you'll actually be able to notice through the aerial photo where these groins are located. And I'll draw about 3 or 4 so you can get the idea of what you'll need to do. So again, we're going to go to Create Feature Arc, and we're just going to draw lines. So we'll start here, and then we'll make our ending position. And I'll draw the same thing for each one of these groins along the shore. All right, so now we want to define these as groins. So we'll do that in the same way by going back to the Select Feature Arc button, and we can double click. Under Arc Options, we're going to name this a groin. We'll click Attributes, and now we have the same type of a menu as the jetties. So in this case, we're going to define all of these. They're all going to be the same. The permeability is 0.1. They are diffracting, and we have a seaward depth of 3 meters. So we'll click OK twice, and now this is going to turn a light blue color. And I'll do this for each one of these groins. So again, we're just going to double click. We're going to go down to groin. We're going to hit Attributes, have the same permeability, diffracting, 3 meters, and hit OK again. So I'll do the same for all of these. So now we've assigned several of these features as groins. I also want to do a few at the very end of our grid because this is a very complex area. And I just want you to see where they're located compared to the jetty. So we're going to draw them here as well. So we'll just go ahead, again, drawing our starting position and our ending position. The starting position is not as important as your ending position because the ending position is going to tell Gencade how long our groins are, how far offshore from the initial position they extend. So again, we're going to go to Select Feature Arc, and we're going to define these as groins. And then again, we'll go to Attributes, and we'll enter in all the information. So that will complete our groins. We're going to go ahead and zoom out again. Before we do anything else, we want to enter wave gauges. I'm going to show a breakwater scenario and then a bypassing scenario at the very end, since these are not actually in this case, but I just want to show you how you would set those up as well. So now I'm going to go ahead and enter my wave gauges. And I'm going to do this and I'm actually just going to enter 3 points along the shore. And in this case, I actually have the XY coordinates of them, so I can just enter those in. So I will click on each of these wave gauge locations. And up here in the XY coordinates, I'm just going to change these very quickly to the location they are. So you see that this position of this wave gauge is actually going to be outside of our grid. So it's going to be assigned to the first cell here. We'll go to the second wave gauge and refine this location. And then do the same for the third. All right, and in this case, we have shore normal convention, so we're going to need to set up our grid first. But what I want to do first is actually define the depths of each of these wave gauges. So I'm going to do this by double-clicking, checking this is a wave gauge, going to Options, and defining the depth as 36 meters. I'll click OK, and OK again. And I'll do the same for the last two wave gauges. Now this one's going to be at 27 feet. And this one's going to be at 24 feet. All right, so we have our three wave gauge locations. Now I want to go ahead and set up the grid frame. So again, in this case, the grid frame is going to start here. If we walk along it from here to here, the shoreline will always be on your left. So we're going to click on Create 1D Grid Frame, and we're just going to draw a line by clicking once and then double-clicking to end it. I'm going to refine the location of this grid, so I'm going to go to Select 1D Grid Frame and double-click on the square. And I'm going to refine my X and my Y origin. And what I should mention is when you create your grid frame, the reason I'm changing the locations of my origin X and origin Y is because these are cases we've already completed. When you start setting up your own case, you probably will not need to change your X and Y coordinates. You may want to change your angle just so it's an easy number instead of, in this case, I've changed it to 200. That's just easier than having an angle of 200.647 whatever. So I just like to use simple, easy numbers, especially if you have your shore normal convention. It's easiest to calculate. And then I'm going to list my eye size as 158, 915. And again, because in this case, we are going to go back, it's really not that important what kind of cell size and number we have here. So we'll click OK, and you can see that it's changed location here. All right, so we have all this set up, and I'm going to go ahead and convert this to a 1D grid before we go through and then enter any more information. So I'm going to go Merge Coverage to convert, Map to 1D Grid, And we're going to go ahead and leave everything as it is and click OK. So we'd have a very, very detailed grid in this case since we just left it at 10-meter spacing. But of course we will change that. So that's actually not as important. We're going to go back through and now we're going to enter all of our wave gauge information. So I'm going to click on Select Feature Point, double click, go to Options. We already have our depth entered, and we'll go to Data. So now under the convention, we'll have shore normal available. I'm going to go to Import, and I'm going to go back under Waves and enter Wave 1. I'm going to go to Next, enter Date, enter Time, enter the height, I'm going to enter the period, and I'm going to enter the direction. And I'll click Finish and OK. And then it will take a minute to load. Now that everything's loaded, I can click OK, OK, and OK again. We have our first wave gauge in. We're going to do the same with the second wave gauge. So we're going to go to Data. We're going to change the convention to shore normal. We'll go to Import. We'll go back to the waves, and we'll enter the second wave information. We'll click Date, Time, Height, Period, and Direction. And we'll click Finish, OK, and OK again. So now we have our second wave gauge entered. And we'll just do the same thing for the last one here. We'll call this shore normal convention, Import, go to Waves, Wave 3, Next, Date, Time, Height, Period, and Direction. And we'll click Finish, OK, and OK. So now we have our 3 wave gauges. I'm going to click and I'm going to save it again. Click Yes. One of the reasons it's entered that we have inconsistent wave values is because we don't have any waves yet in our Gencade grid. We've just entered them in the conceptual model, but the Gencade grid has no idea that we've entered that. So once we go back and reconvert to our 1D grid, that error will go away. So the next thing I want to do is just show you very quickly how you would set up a detached breakwater or bypassing. So I'm going to do the breakwater first. And just as a reminder, this case doesn't really have any breakwaters or bypassing in it, but I'm just going to show you if, for example, you wanted to add some type of an alternative. So if for some reason you wanted to add a detached breakwater in this area, we can do it the same way as many of the other cases. So we'd go ahead and click again on this Create Feature Arc. And say for some example you wanted to protect this area of the shore. We could just draw a breakwater. So we draw one point and then double click. So this probably is not going to be where you'd actually have a breakwater or the distance offshore or the distance of the breakwater. But I just want to go through this, show you what it looks like, and then also really exaggerate it because I'm making this probably larger than you would make your breakwaters. So I'm going to go ahead and I'm going to click on Select Feature Arc, and I'll double click on the detached breakwater. Under Arc Options, now I'm going to name it Breakwater, and I'll go to Attributes. So the first thing that you'll see is we have our Depth 1 and our Depth 2. What this refers to is the depth at each of the tips. So this would be Depth 1 because remember, your grid starts here and it will extend in this direction. So this will be Depth 1, and this side, this end, will be Depth 2. We're going to keep the depth constant at both sides, and I'm just going to say that it is, in this case, I'm going to enter it as 8 feet. One thing that you can do is we can have constant transmission or variable transmission. So if I just leave this as the default as constant, I can enter my permeability here. Or I can go under transmission, I can click this, and then I can add in the equation representing my variable transmission. So if I was interested in using Aaron's, I can click on it. Instead of just entering one value, I can go here, click on this new button, and then I have all these additional parameters that I would enter and Gencade would solve based on those equations. I'm just going to cancel that and just go back to the constant, but you can see that you will have additional information that you would need to enter for any of those variable transmissions. So I'll just enter this as 0.3, click OK, and click OK again. And now the breakwater is going to turn orange. The last thing I want to show you is if you have some type of bypassing event. We're going to go back to Shinnecock Inlet, and in this example we're just going to say that we're going to have some type of bypassing, mechanical bypassing at the inlet. So to do this, I would click again on Create Feature Arc, and then I would draw my location here, and then here. Then I would go to Select Feature Arc, double click, and then I'd go to Bypass Event. Under Attributes, I would list my beginning date, my end date, and then the bypass rate. And notice we're in cubic meters per hour, so this may not be the rate that you have in front of you, so you may need to calculate this. So for this event, I'm just going to say it occurred from January 1st, 1983 to January 1st, 1985. And in this case, we're going to say we have a negative bypassing rate because we're moving the sediment from one side to the other. So I'm going to say it's a negative 5.7 cubic meters per hour. And I'm going to click OK. And now I can do the same thing on the other side of the inlet, where I'm going to say again, this is a bypass event. We'll go to Attributes, and I'm going to specify the same date starting and ending. And then I'm going to have a positive bypass rate of 5.7. And I'll click OK. The last thing I want to remind you about is that we have the option to have variable grid sizes. And for some example, you may be curious and you may want additional information in one area. So say you're mostly interested right here where we have this jetty here, an inlet, multiple groins, as well as a seawall. We may want to have additional detail here. So in order to do refine points, we can do this in one of two ways. we can click on the Create Feature Point, and for this case, I'm going to have 2 refine points. I'm going to list them here and here. Then I'm going to go to Select Feature Point. I'm going to click, and instead of having a wave gauge, this is going to be your refine point. I'm going to specify the base cell as 50, and then hit OK. I'm going to do the same thing on this side. So I'm going to double click. I'm going to go to Refine Grid in the I direction, and I'm also going to say 50. So now, if I want to go back and I want to convert to 1D grid, I'm going to go Convert, Map to 1D grid. This Map to 1D grid window will open up. Instead of having a defined cell size, I'm going to say Use Refine Points. I'm going to change the maximum cell size to 200 meters, and I'm going to change the maximum bias. Again, this is how much each cell is going to grow, to 1.08. And I'm going to say I do not want to use intergrowth, so I'm going to uncheck it. And I'll click OK. So now we're actually going to have a different grid setup. You'll see we have our wave information. We also have all of our other information for the breakwaters and the bypassing also entered. If I zoom in this area where I have the additional information, you can see right away that we have a constant cell size between the 2 refined points. And then it gradually increases until we get to the largest size. One other thing before I finish this case is there's another option here. So I'm going to remove these wave gauges. This can be done by clicking it once, hitting the delete button, and saying yes. So in a second example, you may want additional information here. We can also say that we just want 1 point here, and we want it to grow outside of that. And we're going to say the base cell size of 50 feet. Now we're going to go back and develop our 1D grid. And instead, I'm going to say use intergrowth. Now click OK. The reason we got that, that pop-up about the seawall is because the cell spacing in that area is much larger now. So based on the way I've drawn my arc, the seawall is actually not going to look like that based on the cell sizes. So with seawalls and other things like seawalls, you probably will need a smaller cell size. So here, what you can see has happened is we have the smallest cell size at the inlet, and it's grown in both directions from there. So if we keep this as our case, we can go ahead and go to Jenn K Data, and we're going to specify all the information. So we'll go Gencade to Model Control and enter everything for this case. So first, we're going to start and enter our start date and end date. We're going to start it at the 1st of January, and it's going to be 1983. At midnight to January 1st, 1995. And our time step is going to be 1 hour, and our recording time step will be 168 hours. We're going to go to our beach setup. We're going to modify our effective grain size to 0.3. Our average berm height is going to still be 1, but we're going to change our closure depth to 8. We're also going to modify our K1 and K2. We're going to change K1 to 0.3 and our K2 to 0.15. And then for this case, we'll just use all of our defaults under seaward boundary condition, and additionally, we're just going to use the defaults here as well. We'll click OK. I'm going to save the case again. And then we'll go to Gencade and run Gencade. Now I'm not going to run this case just because I haven't set up everything that was set up in the actual example, but I do just want to, again, just show you quickly how we would do this case, or how we would view the results. So I'm going to exit this and then bring in the information for the input and output files for the main case. So I'm going to go to Input and I'm going to bring this in. Now I'm going to go to the output files and just bring in the .slo. Again, remember, this is your shoreline file. So in this case, you're going to see that we actually have time steps that are not referenced to the date. So we're going to go time steps. We're going to right-click, and we're going to go to time settings. And now we have the 0 time. I'm going to change this to January 1st, 1983. I'm going to go and change display as to absolute date and time and click OK. So now we have actual dates. And I can scroll all the way down and compare the last date to my first date. And I'll just zoom in here. I don't have any of the aerials in this figure, but you can see what has happened over time. Or you can just go ahead and take a look and you'll see how this changes over the entire simulation. And again, you can always go to Display, to Plot Wizard, and view here as well through Gencade, Shoreline Change, going to the specified time step, and clicking on whichever time step you have interest in, going to Finish, and then going to Shoreline Change. You can see how we have shoreline change over time. So with that, that is going to conclude the part of this webinar that we actually go over the Gencade capabilities in the SMS. Now I want to go through and briefly touch on what our future capabilities are with Gencade and where we're going, because we do have a lot that we are working on at this time. So I'm just going to go through this presentation. It is on our website if you want to look at it on your own time. But we do have a lot of new capabilities. As you remember, we have released Gencade version 1. Version 1 release 1 was released in April, and now we have version 1 release 3, which is what you have access to with your SMS 11.1 license. That's included under models. We're also working on version 2, which is going to continue adding to those capabilities. So these are some of our FY13 activities. We have a lot of different activities and a lot of activities that are ranging from different activities. So the first one, which Rusty is actually going to talk about more in his presentation and demonstration, is the need to have the option for Gencade to accept forcing from an external wave model. Right now we don't have that option. It's all in an internal wave model. So the idea was that we could use some type of external wave model, and this would help us, especially in conditions where you have the shoals around an inlet, but with an internal wave model, we can't take that into account. So here we have CMS wave. This is actually going to be the output from CMS wave will be used for the Gencade inputs. Another activity that we're working on is using Gencade output as an input to create an SBAS calculated sediment budget. This came about because Gencade is used for sediment budgets. And we thought it would be really easy if we just had, when you ran Gencade, some type of output that would be in the right format that you could just directly load it in SBAS to start helping you create your sediment budget there. The next activity is variable alongshore parameters. Now this one came about from the Onslow Bay case. That was a very long shoreline. We were looking at more than 100 miles. And over that distance, we did know that we had changes in the depth of closure, grain size, and berm height. But unfortunately with Gencade version 1, we can't alter that. We can't have any changing parameters over the course of your entire grid. So this is what we're going to do with variable parameters. We're going to start having multiple depths of closure, grain sizes, and berm heights along the shore. That's also going to feed into having varying K1 and K2s. Those again are your calibration coefficients. So that I actually have a slide on, I have a picture on the next slide that shows that a little bit in detail. And then variable structures and failure. Right now we have the option with beach fills, bypassing, and dredging events to define a starting date and an end date. With all of our structures for jetties, groins, and seawalls, we don't have that option. So in the menu right now, what would happen is your groin or your jetty would have been constructed before the beginning of your simulation and would remain in the same condition until your simulation has been completed. What we want to do is add the option to have a beginning date and an end date, just like the beaches or dredging events. So what this would allow us to do is we would have the option of, in an example where you have a 25-year simulation and you wanted to construct a groin after 10 years, you would have that option. And in the same way, if you knew that a structure had failed or it was removed in the time of your simulation, you could do that as well. And then I want to talk a little bit about some of the additional documentation during this FY. The first is we're working on a technical note about standard methodology for calibration and validation. This will include a statistical toolkit, and it will also include recommendations for statistics for acceptable calibration and validation. And it will present a standard unified approach. That's something we're still working on this topic. It will be, we'll be working on it through the FY. We may or may not have the TN finished by the end of this FY. And the last thing is that with our Gencade version 2, we will release that this FY, most likely next summer. And that will include variable parameters and structures, the output files for SBAS, as well as code enhancement. And with code enhancement, we actually in version 1, release 3, we do have improvements in the code, which are already there. Those will continue on in version 2 of Gencade. We haven't decided yet if cross-shore transport will be available in our version 2 release. If it is ready, if we've gone through enough testing, then we'll have updated documentation and it will probably be in technical report format, just because cross-shore transport will require more information than just a tech note. Now, if we just have variable parameters and structures and the output files for SBAS in version 2, we'll probably just have that in a tech note format. That will be in our wiki page, so that will actually be easier for all of you because it requires less review. We can get it on our page more quickly, and that means we can get that out to you when we get the version released, so you don't have to have any difficulties working with that version. And then at the bottom of the page, I do have a little example that shows if you have varying K1 and K2 and non-variable. And in this very simple case, you're not seeing that much of a difference in the net transport, but you can still see near the inlet we do have some changes. So that's just a little illustration of what you can expect when you have those variable parameters. And then the big thing we're working on right now is cross-shore transport. This will most likely continue on beyond this fiscal year. And one of the reasons for that is that it's very complex. We've been working on this for quite a while. It's actually not within Gencade yet, but over the next couple weeks we should be getting that code and start implementing it into Gencade. Then we're going to need to start testing it, and depending on how long that testing takes, we may or may not have cross-shore transport available this FY. So some of the processes will be overwash, wind-blown sand and dune building, erosion of berm to deposit in the offshore bar, as well as offshore losses. Also with the cross-shore transport, as I said, it is going to be fairly complex. One thing that we have been thinking about is having our regular Gencade version 2 without cross-shore transport available, and then releasing a separate version with cross-shore transport turned on, or that capability that you would be able to have. One thing that you might want to think about with cross-shore transport is that we may have it all within the model, but it may take a little bit of time to get it all in the interface, because we'll definitely need to have more capabilities in the interface to have cross-shore transport. So it's possible when we start releasing cross-shore transport, it may just be in advanced cards where you actually turn on cross-shore transport. But if that is the case, even if we can't get it into the interface immediately, we will get it into the interface eventually, and we will have documentation for you so you'll understand how to use it. And then the last thing actually feeds into some other applications or activities. And this is spit growth. This is something that we want to develop because when you're looking at inlets without jetties, we do have spit growth. And you'll notice this is just an example of, even with the jetty, how much the spit has grown over time. So we definitely want to start including that in Gencade. And with that said, that actually feeds into inlet and barrier migration. Because over time, if you're looking at a 40 or 50-year simulation, your inlet is probably going to migrate, as well as your barrier island will probably migrate. Eventually, we would like to include inlet opening and closure, but that will probably be beyond this FY. So those are just a couple of the ideas we have that we've either started working on or are on our horizon to start looking at very soon. So I just wanted to give you an idea of what we have coming up. So with that, I'd like to go ahead and turn it over to Rusty, and I'm going to go ahead and turn it over to Rusty, and he will go ahead and start talking about the wave conversion tool.
Yes, thanks, Ashley.
Sure. And I think it looks like I have your screen up, so we should be ready to go.
Okay. Okay, I'm Rusty Fermenter. I am working on a tool that takes CMS. There we go. All right. Takes CMS wave output files and brings them into a .map file format. Ken Connell is helping me with this research. Basically what this does is it converts CMS wave observation stations to .map files that are usable in an SMS, and it also allows you to insert a wave station into your existing Gencade files. So if you have a .gen file developed already, you can go ahead and just input it directly into the .gen file. What CMS wave is just, it's a nearshore spectral wave model. It allows for wave modeling in and around inlets, which is especially beneficial for Gencade since we're trying to do more with inlets instead of, like in the past, Genesis has used ST wave as an external wave model. You can use save stations in order to monitor certain grid locations. And the additional features of CMS Wave include grid nesting, wave-wave interaction, and wave overtopping. What's a tool? Once again, it converts CMS Wave observation stations to .map files usable within SMS, and inserts wave stations. Crap. All right. The purpose of this is it accounts for the presence of nearshore bathymetry in the model. It allows you to compare different bathymetries if you're building like an offshore berm, or if you're doing a dredging project, you can determine if the bar areas are in the best location possible. In the past, Genesis has been used for this application, and this is an example of Ship Island. And they are rebuilding Camille Cut. In the 60s, when Hurricane Camille came through, it cut a channel in the midst of Ship Island. And now they are trying to repair the channel, and they were trying to determine the optimal location for the dredged areas. And you can see that there's a great difference in the mean alongshore transport rate between the existing condition and the dredge condition. And so the dredge condition is with a borrow area immediately offshore of Ship Island. Here's the final position difference. There is about a 50-meter or 45-meter position change from the initial, or from between the borrow area, or the bathymetry with the bar area and the bathymetry without the bar area. And that if we hadn't used an external wave model, that change wouldn't be visible and wouldn't be present, because we would just assume straight and parallel contours all the way into from the wave station used all the way into shore. So the first step of developing the CMS to map tool, or using the CMS to map tool, is developing your wave spectra. The waves may be inputted in the CMS wave as either in a historical time series or a set of representative wave conditions. What that means is that if you have you can either use just the straight up time series from your wave, like your WISP station or your national NDBC buoy station, or in order to save computational time, you can use you can bend those wave conditions into height, period, angle bands, and use those representative conditions as your wave conditions for your Gencade runs. Of course, the waves must be bent prior to use within CMS wave for each set of wave conditions. And we have recently added the ability to divide into seasonal distributions for each characteristic event. So you can divide like anywhere from monthly to seasonal, or you can just do yearly data. And the spectrum can then be generated by inserting the representative wave conditions into CMS wave. So how to do that? First of all, you have to decide the bend limits. And then you find the average height, period, and direction for each bend. And determine the percent occurrence out of all your events for each bend event. And then write the percent occurrence file for the input into CMS to map executable. And this is an example of a percent occurrence file. Each row represents one bend event. So say you had a bend from 98 degrees to 75 degrees with a height band of 0 to 4 foot, and then a period band of anywhere 3 to 5 seconds. And that would be your first event. So this is your first event over the first 3 months of the year. Is your the first column, first row. The first row, second column is your next 3 months. And then the third column is the next 3 months, and then the fourth column would be October through December. And so you do that for every single wave event. So you can do it for either your time series, or you can do it as a representative wave, like are your bin wave conditions. So this would be your first event, your second event, your third event, and so on, and then we read that into the CMS wave. So once you get your bin wave conditions that correspond to your percent occurrence file, you go in under your CMS wave menu in SMS, click on spectral energy, and once you click on that, you will this menu should pop up, which will allow you to create a spectra. The first thing you need to do is you need to create a grid that will cover all your wave periods. So you bring up and you choose your delta, your minimum, and your maximum. And once you have your grid, you can go in and right-click on the new spectral grid and click on Edit Spectra, which will give you the menu, this menu. So what you need to do here is you need to take all your bin wave condition or your wave conditions and copy and paste them into the angle, height, and period. You need to create an index for them. And gamma and the spreading factor are the default's 3.3 and 4, but if you click on spectral defaults, you can see what it is for increased wave periods. And your gauge depth, of course, is just your gauge, like whatever your offshore gauge depth was. Or if you need to, sometimes it may be necessary to bring your gauge depth in using some kind of WIS phase 3 transformation to allow for the depth change from your gauge to the corner, the edge of your CMS wave grid. And so once you copy and paste, you just hit, you export that, and then you name it whatever your CMS wave run is going to be, and that will create a .gen file that will be used in your CMS wave runs. So now that we've created our .gen file, we need to create observation points, and these will be our stations. You want to create the observation points immediately offshore from your largest wave breaking. So in order to select these observation points, you need to click on the Select Cell button. You can hold the Shift key while selecting multiple stations, and then after that, you right-click on the screen, and then select the Cell Attributes tab. And so you can see that we've selected 6 or 7 wave stations. And what this Cell Attributes tab initially will pop up as default, and you need to change that to Monitoring Station, and then click OK. And then once you do that, you need to resave your .sim file for your CMS wave runs. Otherwise, it won't register that you changed the monitoring stations. And so once you do that, you need to we need to write the .ctrl file for CMS to map. And the .control file contains all the cards necessary for CMS to map to write to either an existing Gencade grid or a .map file readable in SMS. And here's all the cards that are necessary. Of course, you need your sim file, and I'll show you an example of this file later on today. These first 4 required input is just a .sim file, your .std file, your .dp file, and your cellheights.out file, which is what the observation stations output for each wave event. CMS time series flag indicates whether you want to process it as just a time series. And what that will do is, if you just put in a time series, you don't have to do the percent occurrence file. You just put the time series in, and the CMS to map will just repeat the time series results for however long you want the Gencade run to be. Or you can do the steady state mode, well, shoot. Then that will be the bin waves over and over. Like again, the frequency file or freq file is the frequency of currents file, and that shows how often each wave event occurs for each season. The number of time bins is just the number of time periods to distribute the output time series over. This is just one for initially, but if you're going seasonally, it'd be 4, or if you're going monthly, it'd be 12. We also we also added a feature to where you can randomize your wave distributions. If you put on the random flag, if you put 0 in, it's just the same order as your input wave events. Which and then if you put 1 in, there's a it creates a randomly distributed array of your wave events with the same probability of each wave event occurring compared to your input wave. All right. So on the format out, that allows you to choose if you want to do an SMS map file versus the Gencade wave files. If you want an SMS map file, you type in SMS_map_wave_file, and the Gencade wave files will be Gencade_wave_files. The map file, this card is just your file name. And all these cards probably just need to be, you don't have to do a path, you just need to keep all these cards in the same folder, or all these files in the same folder, and run out of the same folder each time. You have your start date, your time step out in hours, your time step, or your length of simulation, which is in this case a year. If you have a existing Gencade file, this is your name. If not, and you still want a Gencade, or you want a .gen file, you can insert an origin, the azimuth, and your incremental, like the number of grid cells and the size of each grid cell. And I'll show you an example of the control file in a minute. So now that you've written this, you should be able to just run the CMS to map executable within the same folder as the .control file or .ctrl file, and all of your input files. And then once you run it, you can import your .map file, and it should look something like that. So now I think I'm going to go through just a brief example of how to run CMS to map and go over an actual .map file. So this is my first, this is just a case I've already, you can see that I've already chosen like 5 observation stations, and we can add a few more. So what we're going to do is we're going to go here and select the grid cell, and then left click on wherever you want the grid cells located, and then right click on your screen, go to cell attributes, change from default to monitoring station, and then click OK. And we want to save our project as a resave our sim file in order to get the observation stations to register. And then we go to our spectral energy. In this case, I've already got my spectral grid in order, but we're just to make it short, I'm going to run one wave case. And while we're doing that, let's look at the example control file. So here's our example control file. You can see that all our cards, basically it's just our CMS wave files are the first four. So you have the final.sim, final.std, our cell.out, which is the output of the CMS wave observation stations, final.depth, the frequency occurrence file, which and this is our output file, so that will eventually be our wave stations, our time step, our time series length, our number of time bins, the time series date. We're in steady state mode. We wanted a randomly distributed temporal distribution and our SMS map wave file. And this is just our Gencade file name in the case that we did want a Gencade file, but you can see that we've commented this out with the exclamation points. I think I'm just going to abort that for today. It's going to go too long. But I have an existing .map file that I already created for earlier today that I'm going to load in now and show you what. So you can see that the wave stations that we did have already are there, and if you click on them, you can check out the data for the wave stations. And now once you're here, you can go ahead and make your Gencade grid and merge the coverages, and you will have just wave stations along the course of the grid. And I guess that's pretty much all I have for today. You should be able, I'll put the control files. Let me go ahead and show you the cellhots.i or selhts file. This is the output file of each observation station, and so these are the grid cell, or the your CMS wave grid cells. This is your wave height, your period, and your direction, and this is just the wave event index. There's the one. So, and all this information hopefully will be on the website soon, and I'll have a better example for you in next week, or in the next few weeks. And I think that's all I have for today, so I guess I'll turn it back over to Ashley, or we can go.
All right, thanks, Rusty. I think that gave everyone a good example of one of our new capabilities. And as I said, I thought we'd probably be done fairly early today. Rusty's example and his presentation will be up on the website soon. We'll have the presentation up either later today or tomorrow at the latest if you want to download that as well. And I think Rusty had said he'll probably have a new demo that will be up sometime next week. And again, as I had said before, we will have the videos up as soon as we can get them uploaded. It will probably be early next week, but we'll have those available for you also. So I think, unless we have any last-minute questions from anybody, that we will go ahead and finish the webinar. We really appreciate all of you spending the time with us over the last couple days. We hope that you learned a lot and that you are interested in Gencade and that you'd like to use it in the future. We we gave you that license code that is available for until the end of December, so you'll have some time to work with Gencade, see if you want to start using it for any of your projects. Also, you have Tanya's, Rusty's, and my contact information. If you need to contact us about anything, we're more than happy to work with you, and we can help you get an answer to any of your questions. So I think that is everything. Again, we're just, I think this webinar worked out really well. We'll probably send you a survey in the next couple days asking you how you found the webinar, if you thought it was beneficial for you, or if you prefer a workshop setting. One thing to mention, during my presentation earlier today when I did the Long Island case, it was all in meters. I just misspoke a little bit about feet. So just if you do watch the video back, everything is in meters, and you can see that in the display everything was in meters. I just misspoke about feet. So with that said, I think we'll finish it up. Thank you again for staying with us for the entire webinar. And again, if you need to contact us for anything, just let us know. So thank you. Have a good day.